Hello everyone, welcome to TechWeb. In this session, I am going to discuss object-oriented programming and all its basic features. So this tutorial is completely focused for beginners only. So as you can see, I am going to cover a lot that contains object-oriented programming, classes, fields, constructor, static classes, abstract classes, field class and interface a lot. So let's start without wasting time, and we will understand every concept with very easy code example as well that will really help you to understand in a better way. So let's move ahead without wasting time. Basic object-oriented features that are parts of C# language we are going to discuss, and the tutorial expects that you have a machine setup for local development. If you are using Windows, Linux or Mac OS, you can download Community Edition of Visual Studio with C#, which is completely free. And if you have basic understanding of C#, that will be very helpful. And I strongly suggest you to watch the machine setup session that I have earlier recorded in ASP.NET Core tutorial series, and that link is given in the description of this video. Okay, so our car is ready. So let's move ahead to discuss all points with very easy code example. C# is a powerful, popular, object-oriented language intended for use in .NET. Full support for object-oriented programming included classes, interfaces, inheritance, virtual function, operator overloading, and lots more concepts. So don't worry, I will discuss every concept with very easy example as we move ahead in this session. Okay, so according to the definition, object-oriented programming is an approach to programming that breaks a problem into multiple objects that interact with each other. Okay, we are dividing the problem into multiple objects, and objects are created from template known as classes. So you can see I have created this one diagram for you. So the outer layer I am just depicting in this way. Think it is a complete class, and that contains inner layer is one is data member, another inner layer is member function, and the innermost one is constructor. So these are the most common members for any class. Okay, if we create object of this class, then you can see we have to provide the name object, which is Toyota, and in case of data member values, we specify color is red, and let's say year of manufacture is 2021. And then the inner layer, which is member function, if you will compare these two, which is start and stop, it is a basic function of any car. And the most inner one, which is constructor, so there constructor we use for initializing the values. I will explain in detail what is constructor, member function, data member and car, but this is just to summarize what exactly how a class look like and how its object look like. Don't worry, I will show you in Visual Studio Editor as well how it's look there. But before that, I want to explain these two terms, which is reference type and value type, because I will use these two terms again and again throughout the session. So I thought it will be better for you to understand what actually reference type and value type. Okay, so according to a definition, there are two kinds of types in C#, reference type and value type. We generally apply these reference and value type on data types, like we have integer, which comes under value type, like we have string, as you can see on the right hand side, which is example in .NET editor, it is of reference type. Okay, so let's go by definition. Variables of reference types store references to their data, which we call them object, or memory address instead of value. It means they don't contain data, they only store the address of data. With reference type, two variables can reference the same object. Therefore, operations on one variable can affect the object referenced by other variable. Okay, so let's take an example on the right hand side. You can see we are creating one string A, which is hello. We are creating another string, which is B, in which we specify only one character, which is H. Then we are appending further letters in string B, which is ELLO. Then it's complete hello. Okay, and then if we compare it in C# language with console application, if we compare A double equal B, then it will return true. Yes, it is equal because the value is hello in both string A and string B. But if you will compare the reference with the help of object method, reference equals, then it will return false because they are separate object in the memory. And I will give you one more example in terms of how these things are implemented in actual memory on our system. So when we use value type, then everything is created inside stack and the value is also contained inside stack. It means we use stack when we have defined structure, we know how much memory is required to use that variable. If we use reference type variable, then the variable of reference type will be declared inside stack, but its value is stored inside heap, and the variable which is there in stack, that contains only the reference of that value, so it can access whenever it is required. Okay, so I hope it is clear. You can see here I place here asterisk and pass as a parameter. So why I mention here is because if you will pass a string type variable as a parameter to any function, so if you will make changes in that function, in that variable, so ultimately those changes will also be there outside of that function as well, because that parameter is of reference type. Okay, so if we compare it with the value type, so variable of value type directly contains their data. Value types, each variable had its own copy of data, and it is not possible for operations on one variable to affect the other, like it is completely different from reference type, except in case of ref and out parameter variables. And class, interface, delegates, array are the different reference type which are available in C#. So when you create an object of particular class with new keyword, a space is created in managed heap that holds the reference of classes. So you can see all the reference type, either it is a class, interface, delegate, array, so all their memory allocation when we use new keyword, that goes to heap. Okay, so I hope you have some basic idea what is reference type and what is value type. So let's move ahead from here. So now you can see on the right hand side, you can see some piece of code which is ultimately a class which contains constructor. It contains two properties, color and year of manufacturing, and it contains two methods, start and stop, that I shown you earlier. And at the bottom we are creating new instance of this class, because I believe the practical way is the best way to understand anything, but definitely there are some important points required that you should not miss. So let's go first by definition. A class is a reference type. At runtime, when you declare a variable of reference type, the variable contains the value null until you explicitly create an instance of the class by using new operator, like I am showing at the right bottom. When we are creating object of the car, then we are giving the name of this object Toyota, and we are creating new keyword and we are giving two round braces with car name. Okay, it means we are creating object and memory will be allocated on the heap, or we assign it an object of a compatible type. So this is simply a class. And few more points. Classes are declared by using class keyword. You can see we are using class keyword here, followed by a unique identifier as shown in an example. Because public is used in this case, anyone can create the instance of this class. The name of the class must be a valid C# identifier name. So don't worry about the keywords. As we progress through the course, I will explain what are access modifier. Okay, so class body, where the behavior and data are specified. When we say data, so it is there in our properties, and when we say behavior, it contains in our start and stop methods. So we call them data member and member function. So field, properties, methods and event on a class are collectively referred to as a class members. So we will consider these all are class members. When the object is created, enough memory is allocated on the managed heap for that specific object, and the variable holds only a reference to that location of said object. There is one more advanced point. Types on the managed heap required overhead both when they are allocated and when they are reclaimed by automatic memory management functionality of the CLR. So CLR is common language runtime, which is really helpful to manage the work of automatic memory management functionality, which is known as garbage collection. However, garbage collection is also highly optimized, and most scenarios it does not create a performance issue. Automatic memory management is done by garbage collector, which is a part of CLR. Let me show you this example in Visual Studio. As you can see, this is my Visual Studio and this is the solution, which is a ASP.NET Core application, and in this you can see I am in this folder, which is Object Oriented Programming System Basics. Okay, and I am on this class. My class name is myclass.cs. okay, this class is here. Okay, and in that class I am creating the same class that I just shown you, but it contains the actual information, what are the parts in my class. Okay, so as you can see, these two are the fields. Okay, and this is the constructor. In that we are initializing the property of this car. Okay, and this is the property we are implementing in inline. So we are getting the color and we are setting the color here, and this is another property which is year of manufacturing, and again we are getting the year of manufacturing value and we are setting the year of manufacturing value. And we have two functions as I shown you in the presentation. One is start and one is stop. Okay, so when we create the object of this class, so for example I create one more class and there I am creating the object of this class. You can see this is the same car. If I select here, hit F12, so I will go to this car. So it means I am using the same class that I am just explaining to you. And here if I type okay Toyota dot, so you will see all the members, which is color, which is a public property. Okay, it is YOM, which is a public property, and methods as well. Okay, so I hope it is clear how it actually look like in Visual Studio. So let's go back to the presentation. So now you have seen this car property. This is not actual Toyota, but I am just depicting it. So let's move ahead. Another important feature, another important segment is objects. So let's go by definition. An object is a building block of an object-oriented programming. This building block encapsulates part of the application, which may be a process, a chunk of data, or more abstract entity. So if you think the encapsulation and abstract, these terms are not clear, as I move ahead in this course I will explain these points in detail. Okay, the type of an object is known by a special name in object-oriented programming. It's class. If you can recall, in the previous example we create the object of the car and we give it a name Toyota. So what was the car? That was a class. It means it is a type. So the same statement is written over here. The type of an object is known by a special name in object-oriented programming. It's class. The phrase instance of a class and object means the same, but class and object means fundamentally different thing that I have shown you. Class is just an entity, it contains everything, and object is something where we specify all its important functions, data member, and all other things. Okay, so the fundamental idea behind object-oriented programming is to combine into a single unit both data member and member functions that operate on that data. Such units are called objects. Okay, so now you know better what actually object is. Even I also prepare a visual presentation for you. So when I click on Toyota, we see year of manufacturing is here, color properties here, start and stop function is here. So let's move ahead further. What is field and properties? So as I shown you in example, color and year of manufacturing are two fields which are private, and we are using these fields in implementing the property. Okay, so property contains getter and setter. Getter means when we want to fetch the value from this property, so it will be written by this variable, and when we want to set the property, or you can say the value of this color property, then setter will be called. Okay, so you can see here in color we are assigned the value. Okay, so that's how it looks like when we implement the properties with the help of fields. Okay, similarly we have year of manufacturing as well, and we are using inline property setting. Okay, but let's go by definition as well. What actually it says: field and properties provide access to data contained in an object. Now we already know what is object. The object data is what differentiates separate objects, because it is possible for different objects for the same class to have different values stored in properties and fields, because as you saw earlier, we create one object Toyota. You can create n number of classes with n number of names and with n number of data. It's completely up to you. The various pieces of data contained in an object together make up a state of that object. However, properties differ from fields in that they don't provide direct access to data. What do we mean by this? When we say we don't provide direct access, you can see here we are using private keyword here. It means these two are not directly available. What is available? Only color and year of manufacture, because these two properties are public. Okay, and there is one common practice to make fields private and provide access to them via public properties. This means the code within the class has direct access to data stored in the field, while the public property shields external users from this data and prevent them from placing invalid content here. It means only this property can access these private variables. Okay, so it is better to provide properties rather than fields for state access, because you have more control over various behavior. So state is the same thing. It means what is actual data we are maintaining in our object. So read-write access to properties may also be clearly defined by an object. So it's up to you. Either you want to specify only getter or setter, or you want to specify both. When we specify getter, it means it is a read-only property, and when we say specify setter, it means read and write property. Okay, so certain properties may be read-only, allowing you to see what they are but not change them, at least not directly. You might also have write only property as well. Okay, now another important part is what is access modifiers. This is very important part. So according to the definition, to promote encapsulation, so don't worry if encapsulation is not clear, I will discuss in my upcoming session, so stay tuned for that and don't forget to subscribe. So what is access modifier? A type or type member may limit its accessibility. Accessibility means either it is available or not when we are creating objects or when we are using inside our classes. The accessibility level controls whether they can be used from other code in your assembly or other assembly. All types and type members have an accessibility levels. So what we mean by these statements? So you can see on the left hand side, these two are the private variables. Why they are private? Because we applied access modifier. There are many other access modifier, and what are those? Let me explain. One is public, that we are applying on properties. Public says the type or member can be accessed by any other code in the same assembly or another assembly that reference it. And there is one more which is private. The type or member can be accessed only by code in the same class. And private is mostly used when we really want to use nesting of classes. Don't worry, I will discuss further in detail in our upcoming sessions. And what is protected? The type or member can be accessed only by code in the same class or in a class that is derived from that class. It means if any of the class which is driving this car class, so there these properties are also available. Okay, and one is internal. So this type or member can be accessed by any code in the same assembly but not from another assembly. So in the same assembly we can use this piece of code, but when we say we are using another assembly as well and we want to use these properties, so it is not possible. Okay, and when we say protected internal, so the type or member can be accessed by any code in the assembly in which it is declared and from within a derived class in another assembly. Okay, I hope these are the very basic definition of these. You can read it once again. Okay, and another one is private protected. The type or member can be accessed only within its declaring assembly by code in the same class or in a type that is derived from that class. Okay, so when you will actually implement, only then it will be very easy for you to understand. But there is a one important note: access modifier are like gatekeepers. They can control who has access and who can read and modify the things. I hope access modifiers are now clear for you. So let's talk about constructor, what they are. If I recall, let me take you back to the Visual Studio. So here I shown you what constructor is. So this is the constructor, and what it is doing, we are initializing the value of class properties, which is color and year of manufacturing. So whenever an instance of this class is created, these properties are initialized. So we can say here a constructor is used to initialize the properties or the value of that object. Let's go back to the presentation. So by definition, a constructor is a method whose name is same as the name of its class. You can see at the bottom here there is another class which is child, which is inherited by person. Forget about the person and how it is working, I will explain further just after few minutes. And you can see this is the example of constructor. It is parameterized, where we are passing last name and first name, and we are also calling the base class, which is a person class. In that we are also passing last name and first name. Don't worry if this thing is not clear, I will show you this thing in the Visual Studio editor. But let's read some of the important points. A constructor is a method whose name is same as the name of its class. Its method signature include only the method name and its parameter list. Okay, it does not include a return type. Okay, there is no return type, and called instance constructor. Okay, so when we say instance constructor, so whenever a class is created, a constructor is automatically called, okay, which is parameterless constructor. A class may have different constructors that take different argument. Constructors enables the programmer to set default values, as we have just seen, and limit instantiation and write code that is flexible and easy to read. It is private by default because if there is no access specifier over there, so it means it is private. Otherwise we are specifying public, then it is available to all to create the instance. A constructor that takes no parameter is called parameterless constructor, and parameterless constructors are invoked whenever an object is instantiated by using the new operator and no argument are provided to new constructor. If you don't provide a constructor for your class, C# create by default one that instantiates the object and set its data member variables to its default value and listed in its default value of C# type of the new object. The class constructors can also be used to call instance constructor of the base class through initializer that I am just showing with the help of base keyword. So a constructor can invoke another constructor as well in the same object by using this keyword. Like base class, this can be used with or without parameter, and any parameter in the constructor are available as parameters to this. Okay, don't worry, I will show you in Visual Studio as well. A private constructor is a special instance constructor, because when we are talking about constructor, so this is very important part of it. A private constructor is a special instance constructor if a class has one or more private constructor and no public constructor. Other classes cannot create instance of this class when we only have private constructor. You can prevent a class from being instantiated by making the constructor private. It is generally used in classes that contains a static member only. Okay, so we have seen this child and person relationship. Let me show you in Visual Studio as well. This is the same solution, and we are in Visual Studio. So let's move to person class. In that we can see we have two properties which are private, first name, last name, and in its constructor, which is same as of name of class name person without return type, and it is public. It means we can create object of this class when we are passing two parameters, L name and F name, which is the last name and first name. And what we are doing here, we are assigning these two string variables to these two properties values. Okay, so when we will assign these values to here, so it will come here for setter because we are setting the value. Okay, and when we will fetch these values, it will come here at runtime. Okay, so that's how it is looking like in person class. But let me show you in child class how we are using it. So we are inheriting this person class. Okay, and we specify a constructor here, and we specify one more constructor. I mean, this is the case that I really want to demonstrate as of now. I will discuss different case as well. So here we have a class child constructor. In that we are receiving two variables and we are using base keyword. You can see base is demonstrating person dot person. It means it is calling the person class and calling the person constructor. In that we are passing last name and first name. Okay, I hope it is clear now. So let's go back to the presentation. So let's move ahead. I hope constructor feature is completely clear for you. So let me discuss what are methods. So again we can see the same example, but let's go by definition. Method is the term is used to refer function exposed by the object. Like I said earlier, start and stop are the two functions which contains return type which is of void. It means it don't need to return anything. Otherwise in real scenarios it can be a string, it can be integer, it can be task, it can be anything which is actually valid in C#. These may be called in the same way as any other function and may return values. Methods are used to provide access to the object's functionality like field and properties we have just seen. They can be public or private, restricting access to external code as necessary. They often make use of an object's state to affect their operations and have access to private members such as private fields if required. It means this method can access the private field of this class, okay, which was color and year of manufacturing that we have just seen in the previous example. Okay, and another important point is the syntax is very much similar to that of for field and properties, except that the type shown at the end of the return type statement, or it can be void as well, because as of now you can see it is void. It means it don't need to return anything, it is not doing anything. But if we use integer here, so definitely it should return integer type of value from this method. Now we have moved to a static class. It is very important and very widely asked question in many of the interviews. So let's first go by definition. We will see these examples as well. Static classes are created using the static keyword in C# and .NET. A static class is defined as a class that contains only static members. So what do we mean by static? We will just understand in a bit. When a class is declared to be static, it is sealed, abstract, and no instance member can be declared. Okay, if you are thinking what is sealed and what is abstract, so don't worry, I am going to explain just after few minutes. Okay, so when we say static, so we are using the static keyword. Okay, you can see there is a static class. I named this class and I am using the static keyword. And if you declare any member as a non-static member, you will get an error. It means if we specify integer a, it is not a static variable, so at compile time you will get an error. You can see at the bottom I am trying to create integer type variable which is of a, and you can see it is a static class, so I will get error at compile time. Okay, so when you try to create an instance of the static class, it again generates a compile time error. You cannot create instance of the static class because static members can be accessed directly with its class name. Okay, this is the feature of a static class. Okay, you just simplify the type the name of the class, and the moment you will press dot, you will see all the accessible member there wherever you want to use. Okay, a static class cannot be instantiated. You cannot create an object of the static class. Okay, static class members are accessed by class name followed by member name. They are commonly used to provide shortcuts to other operations or functionality, and only single instance work in memory when we use static classes. Now you must be thinking, I just said there is no instance that we can create. Yes, we can create, but that is automatically managed by C# compiler. Okay, so we cannot intervene anything in that process. A static class can have a static constructor without access modifier which initialize static members of the type. Okay, if you want to initialize anything, you can specify constructor over there. Okay, as you can see this system example in front of you, you can see there is one static class which is environment. Okay, so you cannot make any changes in that class. You can also create your own custom static class as well with the static keyword. You can create a static constructor as well, but you cannot call it. okay, but you can specify the things that you really want to do and that you really want to initialize static, okay. And there are few suggestions for a static class. Do not treat a static class as a miscellaneous bucket. It means don't put anything, and do not declare or override instance member in a static class. So when we are talking about class, so constructor is also important. So let's move ahead to understand what is a static constructor, okay. So by definition, a static class can also have a static constructor which initializes static members of the type. Note here, only static member static class can initialize, okay. Static constructors are parameterless. It means we cannot provide any parameter. If you don't provide a static constructor to initialize static fields, the C# compiler initializes static fields to their default values. Static constructors can't access non-static data member, and this is very true. To initialize a static class or static variables in a non-static class, you define a static constructor, and a static constructor are parameterless, okay. You can also define a static constructor with an expression body definition. Expression body definition means we are specifying a static keyword and child using round braces, giving an arrow, which is generally we call them lambda, and we are initializing the static variable, which is maximum age, and giving its value 18, okay. So this is an expression body definition. So static field and properties, the memory will be allocated individually without any relation with object. So that's how it works in terms of memory. Static methods you can also create. These methods can implement operation on static field and properties only and cannot access the non-static members, okay. So let me show you all these things in action in Visual Studio. Now again we are in Visual Studio. So let me go back. As I shown you the example earlier, let me delete here this keyword, okay. So now you can see we have created a static class, okay. In that you can see we are creating a static variable which is allowed, and if I remove it, the static keyword, then again I will get quickly read over here, and that says sample class A cannot declare instance member in a static class. So this is my instance member, or you can say field, or you can say variable, and if I provide static here, then there will be no error, okay. It is allowed. So this is my static constructor with simply static keyword, okay, and in that I can create a number of objects, I can perform anything, I can create local variable as well, and that can be static or non-static, okay. And now you can see I am creating one static method, the name is test, and it is not returning anything, okay. And you can see here I am creating a simple string variable of test_var, which is assigning the empty value. So instead of void, if I specify a string, so I should return the string value from here. So it will be like tu return, and test variable is of return type, okay, which is right, and just save it. So there is no error. So that's how we can create its method, and property is very simple. You can follow the same steps, only you need to specify a static keyword over there. So constructor is clear, method is clear, and variables are clear. Even in this child class as well, you can see this is my non-static class, okay, but I am creating a static property, and if we are creating a static property, that can be used by a static constructor only. So that's why we specify a static constructor which is child, and that can only access static members, okay. So it cannot do anything other than static members, okay. So let's go back to the presentation. I hope static and static constructor is clear for you now. So let's move ahead from here to discuss another very important concept, which is abstract class. So abstract keyword in C# create incomplete classes, okay. You hear right, incomplete classes and the class members. So both are incomplete, and abstract class cannot be instantiated. Obviously, if a class is incomplete, we cannot create instance of that, okay. An abstract class provides a partial implementation that other classes can build on. When a class is declared as abstract, it means that class can contain incomplete members that must be implemented in derived classes. Derived class means, as I shown you, the child and the person class. In the same way, when we will implement this shape class, okay, so the one which is inheriting all the features of this shape class, that will also provide the implementation to all the abstract members, okay, in addition to the normal class member. Don't worry, I will show you all these things in example in Visual Studio. The purpose of abstract class is to provide a common definition of a base class that multiple derived classes can share. It means, suppose for example, in when you will work on real-time project, you want to specify some functionality that should be followed by all the child classes, so you can specify that in that abstract class, and wherever you will use that abstract class as a base class, so by default you will get the feature of partial implemented and you can use in your program. Abstract classes may also define abstract methods. This is accomplished by adding a keyword abstract before return type of the method. As you can see here, we are specifying abstract class, and in the next line we can see this is the abstract method which is get area, and another which is abstract property. We just specify everything is same, only abstract keyword is here, and abstract indexer we can create, abstract event we can create. For event, first we need to create the delegate, then we need to create the delegate type variable that will be called event, and we are specifying abstract that as well. And we can also create abstract classes inside the another abstract class. Okay, so I hope it is clear. I'm showing here, shape can be like this. This is one of the example of rectangle. So let's move ahead to another important part to understand, which is what are abstract members actually. So a member that requires a body can be declared abstract. It means we are not giving the body, we are just declaring that, such as method, properties and indexers that we have just seen. These members are then left unimplemented and only specify their signature, while their bodies are replaced with semicolon. Okay, so as you can see, if we small down our shape class and we specify only one method which is get area, and we specify two internal variable x 100 and y 100, and take example we implement that shape class as a base class in rectangle. So what will happen, we have to provide implementation to get area. Okay, so to implement that get area we should override that. Okay, we will override the integer get area and we will return x into y. It means without specifying any variable, any value, we are just simply returning the area of that shape which is of rectangle. Okay, so let's read few more important points related to abstract members. If a class derived from an abstract class, so it is then forced to override the abstract members. I will show you all these things in example, just wait for a few minutes. This is different from virtual modifier. Okay, we are not discussing virtual anymore in this session, but virtual is something where we specify virtual in base class, and in derived class we provide a new implementation with the help of new keyword or override keyword. So it is optional, but when we specify abstract, it means it is mandatory to provide the implementation. Okay, and this is not optional. The driving class can be declared abstract as well, in which case it does not have to implement any of the abstract class member. For example, we have a class rectangle which is already abstract, and we also inherited shape which is again abstract. It means now there is no problem because both classes are abstract and they don't need to provide any implementation. An abstract class can also inherit from a non-abstract class. Okay, for example, consider there is a class which is non-abstract, and in abstract class we are inheriting that. Then even in this case as well, there is no issue, it is completely possible. An abstract class can be used as an interface to hold objects made from derived classes. We are creating a variable of type shape, and in that we are creating new of rectangle, where rectangle is my child class. Okay, so you have seen this example. Let me show you in Visual Studio as well. So now again we are in Visual Studio. So let me click on this class which is a shape class. Okay, so in that you can see I have declared one abstract class and the name is shape. Okay, and we are specifying two variables x and y, and the value is 100. You can see I have commented all other members just to keep this class simple, and I declare one simple abstract method which is getArea. Okay, and if I implement this shape class in this rectangle, so shape is my parent class and rectangle is my child class. Okay, or you can say the new class which contains all the features of shape class as well, and we can create its own features as well. Okay, so now because we specify abstract in base class for shape, we need to override the getArea method, and we will automatically get the value from x and y. We don't need to do anything because these values are coming from shape class. Okay, so this is the very basic example. If I take another example, suppose we have another class which is already abstract, and again we are inheriting the shape class which is also an abstract class, then it is completely possible. Okay, but now what we are doing, we are not providing any implementation. As you can see, I have created one other method and I am not providing implementation of this shape class method which is mandatory abstract class. Why it is possible? Because I have created this class abstract as well. Okay, it means now I don't need to provide anything, but by applying the abstract class, no one can create the instance of this circle class. So this is the foundation, or you can say restriction applied on this class. Now let's take third scenario where, for example, you specify, you override some of the method, but now for further derivation you want to stop, so that no one can make changes in that getArea. So what you will do, you will implement the shape class. For example, there is a sphere shape we have. Okay, if we apply sealed over here and we override the getArea method, so if any of the class which is inheriting a sphere class will not be able to override the getArea method. I hope it is clear. Let's go back to the presentation. I hope all those points are clear. Let's move ahead to discuss another important class type which is of sealed class type. Okay, so let's go by definition first. Classes can be declared as sealed by putting the keyword sealed before the class definition to prevent further derivation or overridden in the class. As you can see, we can provide new implementation to the base class, but if we apply sealed, so no one can override the features of the base class. So you can see in this example, sphere is my class and we are implementing shape class, and the moment we apply sealed, so no one can override this getArea method further from sphere class. Okay, so that's the power of sealed. And on the right hand side, I take example of existing framework in C#. You can see iComparable is implemented by a string and it is a sealed class. Okay, so we cannot modify anything in this class. Let's take few more important points. They can never be used as a base class. Some runtime optimization can make calling sealed classes members slightly faster. The sealed keyword prevent inheritance of class members. Now, very important point is a method, indexer, property or event on a derived class that is overriding abstract member of the base class can declare that member as sealed. This negates the virtual aspect of the member for any further derived class. So this is accomplished by putting a sealed keyword simply before the override keyword in the class member declaration. As I have shown this piece of thing in practical way, you can specify sealed before override. So now it negates all further derivations. Class shape inherits from class sphere, but no class can inherit from class sphere. Okay, I hope it is clear now. Interface is another important part in object oriented programming. So let's go by definition first. They are defined with interface keyword followed by a name and a code block. Okay, and their naming convention is to start with a capital I. I mean, in most of the companies and most of the programmers follow this convention, but it is not mandatory to provide I prefix. Okay, and then to have each word initially capitalized. Let's take example of this. I specify I as a capital, then I am saying my interface. So this is the way to create an interface in C#. You specify interface keyword and you provide the name of your interface, and in that as well you can see we are mentioning interface method which is int of getArea, interface property which is integer type area, getter setter we have, and you can create indexer as well, you can create event as well. Okay, let's see few more important points. An interface is a reference type that defines a set of members or a group of related functionalities. All non-abstract classes that implement that interface must implement that set of members. It means only non-abstract class can implement an interface. Okay, the interface code block can only contain signature. You can see there is only signature, because in abstract class we can have partial implementation as well, but in interface we cannot specify any implementation. But if you will compare the interface with abstract class, in abstract class we can have partial implementation as well, so that's why that can act as a base class, but definitely interface cannot. The interface member cannot have any implementation. Instead, their bodies are replaced by semicolon. It means where we specify semicolon, we will provide the body in the class which is going to implement this interface. They also cannot have any access modifier, since interface members are always public. So you can note here, in abstract class we specify access modifier as well, but interface we don't provide any access modifier. These are by default public. An interface can't be instantiated directly. A class can inherit a base class and also implement one or more interfaces. Okay, so a little behavior is also same. You cannot create instance of interface. Let me take you through with example in Visual Studio. Again, we are in Visual Studio and I am in my interface. Okay, you can see we specify interface, provide a name, and here this is our interface method, this is property, this is indexer, and this is event. That's what we can create inside interface. Okay, and now you can see there is another interface which is comparable. I have given a name, and in that we have one method which is integer type. There is no accessifier that we can use, and it contains one method only, which is compare, and it is receiving object to compare and just giving its name. Okay, normal. But in one circle class we are implementing this comparable interface. Okay, and we have to provide the implementation and specifying publicly specifier is important, and integer type method it was there in interface, so we specify int compare and object of O, and in that we are returning r minus, any of the calculation that typically your business needs, that you can specify there. So ultimately what I am trying to make is comparable is an interface and we are implementing its method in class. Okay, and there is another example that I would like to show you. This is another interface which is of iCar. Okay, and it contains two methods, start and stop. The very first example that I was using, which was car. Okay, and you can see I was implementing iCar as well, and let me minimize here. Okay, this property as well, this one as well. You can see start and stop is here, and if I make changes, let's say if I press S, okay, now they are quickly read, and what it is complaining, the car does not provide interface member iCar.start. Okay, so it's mandatory to provide implementation to all the members of the interface. Okay, let me remove the S here and press Ctrl S. Now there is no error. So that's the difference between interface and abstract class. Okay, so let's go back to the presentation. There are many other differences that we will discuss in our upcoming sessions. I hope you enjoyed the whole session. I know it was very fast, but I tried to cover every point with easy examples, and don't worry about the piece of code. I will make that available, and the GitHub repo link is given in the description of this video. You can take the piece of code from there and you can use it, and you can practice as much as you can. Okay, I hope you like this video. My next session will be on object-oriented programming pillars, or you can say characteristics, or you can say principles. If you have any suggestion, any doubt, you can mention in the comment box. I will try to reply as soon as possible, and your comment is the only inspiration for me to create such videos. So see you in the next video. Till then, bye bye, and don't forget to like and subscribe.